Close your eyes for just a second and try to picture that a single tiny point, not even the size of the smallest atom you can imagine. That point is so incredibly hot that its temperature is beyond anything our minds can truly grasp. Trillions of degrees, and inside that impossible little point lies absolutely everything that would ever exist in the entire universe. Every star you see on a clear night, every planet that orbits them, every mountain on Earth, every drop of water in the ocean, and that's even every single atom that makes up your own body right now, all of it backed into that one infinitesimal speck. Then, in a single silent moment, 13.8 billion years ago, something extraordinary happened. That point didn't just explode like a firework inside some already existing space. No, space itself, time itself, everything we call reality began to come into being right there and then. It wasn't a loud bang you could hear because sound needs air and air didn't exist yet. It was the birth of the universe in its most fundamental sense. That is the story we call the Big Bang, but it's not just some distant event from a science textbook. It's the story of how everything around you came to be, from the air you breathe to the screen you're watching this on. All of it traces back to that one moment. In the next 64 minutes, we are going to travel back together, step by careful step, to the beginning of everything. We'll see what the universe looked like when it grew smaller than a grain of sand, how it grew faster than light in the first tiny fractions of a second, and how that early chaos eventually cooled down into the vast, beautiful cosmos we observe today. We'll explore the invisible forces that shaped it all, the first particles that formed the very first light that was ever able to travel freely, and how gravity slowly bound everything together into the galaxies and stars that light up our night sky. By the end of the journey, you'll never look at the stars the same way again. You'll understand that the universe isn't just out there, it's still happening inside every atom of your being. So stay with me, keep an open mind, and let's go back to the single moment when the universe was born. Let's start by asking a question that might sound simple, but is actually one of the deepest puzzles in all of science. What came before the Big Bang? The honest answer is there was no before. Time itself did not exist yet. It's not that the universe was empty or dark or quiet, is that the very idea of before or after only makes sense once time has started. Think of it like this. Imagine trying to ask what is not of the North Pole. The question doesn't make sense because the North Pole is the northernmost point. There is no direction further north. In the same way, the moment we quote t equals 0, the instant of the Big Bang is the very beginning of time. Scientists describe the state right at that instant as a singularity. It was infinitely hot, infinitely dense, and all the laws of physics that govern our everyday world simply break down there. Gravity, electromagnetism, the strong and weak nuclear forces. We were all merged together into one single superforce. Let's pause and picture the singularity for a moment. It wasn't floating in some empty space. There was no space to float in. The singularity contained only energy and potential that would later become space, time, matter, and energy. It was like the ultimate set of everything compressed beyond imagination. Some models suggest that quantum effects, the strange rules that govern the tiniest scales, might have played a role even here, but we don't have a complete theory of quantum gravity that to describe it perfectly. What we do know for sure is that something changed at t equal O. The, the conditions were just right for the universe to begin its expansion, and once that expansion started, it was irreversible. The universe began to grow, and it had never stopped since. There is not just a theory pulled out of thin air, it is supported by mountains of evidence we explore together in the coming minutes. But for now, hold on to the idea before the Big Bang. There simply was no before as we understand it. Now we arrive at the exact moment everything changed. At T equals 0, the temperature was so extreme it defies description, far hotter than the center of any star today. Energy, matter, and the fundamental forces were unified in a sitting superdense state, then in the tiniest fraction of second you can imagine, less than a billionth of a trillionth of a second, the universe began to expand. There wasn't an explosion happening inside space. That's what the creation of space itself. Let's break it down slowly. In the first 10 to the power of negative 43 seconds, a number so small as almost meaningless. The universe was smaller than the smallest distance we can measure today. Everything was packed so tightly that our current physics can't fully describe. But as soon as expansion began, the universe started cooling, just like steam expanding from a pressure cooker cools down. The superforce started to separate. Gravity broke away first, becoming its own distinct force. A little later, the strong nuclear force separated, and then the weak and electromagnetic forces followed their own paths. Imagine the universe at this stage as a boiling ocean of pure energy. Particles and antiparticles were constantly popping into existence and annihilating each other in a flash. The cosmos was a chaotic, high-energy source, but here's the beautiful part. Because the expansion happened so quickly, tiny quantum fluctuations, random little ripples at a smaller scale, were stretched out and became the seeds for everything we see today. Though microscopic ripples will later grow into galaxies and clusters of galaxies, it's almost poetic. The tiniest uncertainties at the beginning became the large-scale structure of the universe billions of years later. We talk more about how fast they growth what in the next section, but for now, remember that the Big Bang was not destructive like an explosion we see in movies. It was creative. It was the moment the universe went from being a point of infinite potential to a growing, evolving reality. And every second after that moment made the cosmos cooler, larger, and more complete. Only a tiny fraction of a second after the beginning came one of the most mind-blowing phases in cosmic history. cosmic inflation in an incredibly short period, from about 10 to the power of negative 36 to 10 to the power of negative 32 seconds. The universe expanded faster than speed of light. That's faster than life itself. But don't worry, that doesn't break any rules because space itself was expanding, not objects moving through space. Picture blowing off a balloon, but instead of blowing it up gradually, you inflate it by a factor of 10 in less than a billionth of a trillionth of a second. That's how fast the universe grew during inflation. A reason smaller than a protein suddenly became larger than a galaxy. The rapid expansion smoothed out the universe, making it credibly uniform on large scales, while also stretching those tiny quantum ripples we mentioned earlier into the seeds of future galaxies. Why did inflation happen? The leading idea evolves a special energy field that fueled the early universe and drove that super-fast growth. When that field decayed, it released energy that heated the universe back up, creating the hot soup of particles we'll talk about next. Inflation explains so many things we observe today. Why the universe looks the same in every direction, why it's so flat on large scales, and why we see the patterns in the cosmic background radiation. Without inflation, the Big Bang model would have many unsolved puzzles. But with it, the picture becomes clear and elegant. The universe didn't just expand, it inflated like the biggest balloon in history, setting the stage for everything that followed. After inflation ended, the universe was still extremely hot. About a trillion degrees. It was a primordial soup of quarks, gluons, and other exotic particles swirling in a plasma state. As it continued to expand and cool, things started to organize. Around 1 second after the Big Bang, quarks began to combine into protons and neutrons. A few minutes later, the temperature dropped enough for the first atomic nuclei to form through a process called Big Bang nucleosynthesis. Hydrogen was the first element to appear. About 75% of our normal matter, helium made up most of the rest. Around 25%, tiny traces of lithium and beryllium also formed, but that was it. No carbon, no oxygen, no heavy elements yet. They would have to wait for the first stars to form billions of years later. The primordial soup was still too hot for full atoms. Electrons were flying around freely, scattering light in every direction, so the universe was opaque like a thick fog. Let's imagine walking through the early universe. Everywhere you look is glowing with intense light, particles crashing into each other at enormous speeds. That slowly, as the universe grew larger, the temperature kept falling. But by the time 3 minutes had passed, the first light nuclei were stable. That phase is crucial because it set the exact ratio of hydrogen to helium that we still see in the audio stars today. It's like the universe wrote its chemical recipe right after birth, and that recipe determined the ingredients for every star, planet, and living thing that would ever exist. Fast forward 380,000 years after the Big Bang, the universe had expanded and cooled to about 3000 degrees Celsius, still hotter than any oven, but cool enough for electrons to finally combine with nuclei and form the first neutron atoms. When that happened, something magical occurred. Light could travel freely for the first time. Before that, photons were constantly passing off free electrons like balls in a crowded room. Now the room emptied, and light streamed out in all directions. The light is still traveling today. We call it the cosmic microwave background, or CMB, the oldest light in the universe. It has stretched and cooled over billions of years into microwave radiation, just 2.7 degrees above absolute zero. We located CMB with our telescopes. We're literally seeing a snapshot of the universe when it was only 380,000 years old, a baby picture of everything that exists. The tiny temperature differences in C and B are the echoes of the quantum ripples from inflation, and they show exactly where the first galaxies would later form. The moment, often called the surface of Lux scattering, marks the end of the universe's dark ages and the beginning of the era where light could il- illuminate the cosmos. It is the reason we can map the early universe so precisely and confirm the Big Bang happened exactly as the models predict. With the first light released, gravity took over as the main architect for the cosmos. tiny density differences in the expanding universe began to pull matter together. Over the next few hundred million years, the first stars ignited, lighting up the darkness. Those stars fused heavier elements then exploded as supernovae, scattering carbon, oxygen, and iron into space. New stars formed that enriched material along with planets and eventually the complex chemistry that would lead to life. Galaxies clustered together, fragments of matter spread across billions of light years, and the universe evolved from a nearly uniform shape into the structured, beautiful web we see today. That even now, 13.8 billion years later, the expansion continues. The same force that started at the Big Bang is still pushing galaxies part apart. The universe is not only still growing, it's accelerating. Every moment, new space is being created between Earth and the distant stars. From that single impossible moment, we have arrived at a cosmos filled with wonder, ready for us to explore and understand. From a single point smaller than an atom, hotter than anything imaginable, the entire universe unfolded in a single moment. That moment gave us the laws of physics, the first elements, the first light, and eventually the stars, planets, and life that allow us to look back and tell the story. The Big Bang isn't just history, it's ongoing story of every atom in your body, every breath you take, and every star you wish open at night. We've traveled 13.8 billion years in just over an hour, and we have only scratched the surface. In the next video of this series, we will dive deep into how stars are born, live their dramatic lives, and die, the very atoms that created the items inside you and me. If the journey through the birth of the universe fascinated you, please give it a thumbs up. Subscribe to the channel and turn on the notification bell so you never miss the next chapter. The universe is still expanding, and so is our understanding of how it all works. Thank you